So number 7 says we have a 15-gram marble that's dropped from rest onto the floor 1.4 meters below. So it's like the marble is starting up here at 1.4 meters and it's dropping down to 0 meters. Okay? What does it say the mass of the marble is? 15 grams. How many kilograms is 15 grams? 0.015. Do you guys know how to get from grams to kilograms? You divide by what? By 1,000. You divide by 1,000, okay? We're given our initial height is 1.4 meters. And what are we told is the velocity it's starting from? Yeah, rest. So that's 0 meters per second, right? Yeah? Okay. So let's see what part A wants from us. It says if the marble bounces straight upward to the height of 0.64 meters, what are the magnitude and direction of the impulse delivered to the marble by the floor? So what part A is talking about is that it hit at 0 meters and then it bounced back up to 0.64 meters. Okay, so that's sort of the situation that we're dealing with in part A. Which means that in part A, what is our final height? 0.64 meters. And we are asked to find the impulse. We want to know the magnitude and direction of the impulse. What is the impulse? Okay, so I'm going to tell you right now, you guys picked really wise with number 7. Number 7 is the one that involves the most steps and is the most difficult on the entire problem set. So good job. Give yourselves a pat on the back. So that means that what I'm about to do to solve this problem, you're not going to have to do on anything else in the problem set, okay? This one's a little bit more in depth because this one doesn't just tie momentum in, it ties in kinetic energy, okay? That's why I put it on this problem set. I figured you guys would pick it and then we'd get to like sort of expand on it a little bit, okay? Now, the reason it involves kinetic energy is because isn't momentum mass times velocity, right? So if we're going to find impulse, which is the change in momentum, we're going to need to figure out what the velocity is of the marble right here, okay? And in order to do that, we're going to have to use the conservation of energy that we've learned before, okay? So that means that, like I said earlier, nothing goes away. And we're going to want to write out our conservation of energy equation. All right. So before we figure this out, we could probably just jump right there if we wanted to. Yeah, we can. We need to maybe figure out what our velocity is at the bottom here and what our velocity is right here. Just for some good measure, okay, you guys? So if we want to first find out our velocity at the bottom when it reaches 0, as it hits the ground, right? We need to think about what our initial and finals are over here, okay? Because we're dropping from here to 0. Does everybody follow that? Yeah? Today, is it rough? Your guys' faces look blank. Okay, it's okay. So that means we have an initial height. Do we have an initial velocity? 0, right? So we can cancel that. And it's falling to 0 meters. So we can cancel that. And we're going to look for the final velocity down at the bottom. So we'll have that mgh naught is equal to 1/2 mv final squared. Okay? And I'll just walk you guys through this since you don't seem like you're really here today, okay? So just make sure you pay attention. What we're going to want to do is we're going to want to multiply both sides by 2 to get rid of the 1/2. And then we're going to want to divide by m, which is going to cancel our m's across the board. And we'll be left with 2gh naught equals v final squared. And what we finally want to do to get rid of that squared is we're going to say the square root of 2gh naught is equal to our final velocity, okay? So you do 2 times 9.8 times 1.4, and this is going to give us our velocity when we're hitting 0, like right before we hit the ground, okay? So can somebody tell me what our velocity is right before we hit the ground? 5.24? 5.24 what? Meters per second. Okay? So that's going to be our velocity right before we hit the floor. Okay? So now that we have that, we're going to want to try and figure out what our velocity is at height of 0.64. Okay? And in order to do that, what do you guys think we need to do next? Yeah, we're going to need to find our sort of change in momentum. We're going to need to, in that case, though, find a momentum. So how about, like, we see this as our practice run, okay? So let's find what the momentum would be right before it hits the floor, okay? So remember that momentum is what times what? Mass times velocity. Okay, what's our mass? 0.015 kilograms, right? And our velocity down here at the bottom, as it's hitting the ground, is 5.24 meters per second. Now, question though, you guys, is that 5.24 meters per second, should it be positive or negative? Negative, right? Because it was going down. So who can tell me what our momentum is right before we hit the ground? Mm-hmm. And don't forget that the units are kilogram meters per second, okay? So what we're going to do in order to find what our velocity is up here, yeah, what? Oh, yes, it is supposed to be negative. Good job, good eye. Okay? So what we're going to do to find the velocity up here, we're going to want to do the same kind of thing we just did right here, okay? So we went through, we sort of just did an example of how we would solve for this, and now we're going to solve for what we're asked for, okay? Is there something wrong today? Your guys' eyes look way different than they usually do. You just woke up and it's raining, and I'm sorry, you guys just, something seems really off. Okay, so what we're going to do here is going to take some conceptual thought, okay? Because we're going to want to use, just like we did here, the mgh naught plus 1/2 mv naught squared is equal to mgh final plus 1/2 mv final squared. Okay? Now, why this is conceptual and why this is going to take some brain thought, okay, And why I made you do this first, even though this doesn't have to be done to get the answer, is so that I can explain something to you, okay? You guys understand? I'm gonna try to explain something. So when we're deciding what's 0 up here, okay? You guys know that this is gonna be 0, right? Because it's starting from the ground. Okay. When I was talking about this, did you notice I kept saying this is gonna be the velocity right before we hit the ground, and this is the momentum right before we hit the ground? Okay. When we've talked about stuff in the past, like free fall and projectiles, right? Think about projectiles specifically. When we're doing it, don't they have like a positive velocity, then they hit a velocity of what? 0, and then they change direction to a negative velocity, right? So here we have a negative velocity all the way down, but what's our velocity as it's going up? It's going to be positive. So at some point, isn't this marble going to have to reach a speed of 0? Yes. So when it's actually like on the ground, right before it turns around to bounce back up, its velocity will be 0. So we can actually cancel out both of these in order to figure out what our velocity is going to be up here, okay? So that's why I wanted to show you that this velocity right here that we solved for isn't what we're going to use when we're trying to see when it bounces up, because it has to equal 0 before it can bounce back up. Does that make sense to everyone? Yeah? Okay. So that means we're left with 0 equals mg h final plus 1/2 mv final squared. And we're looking for that final v. And we can still find it, can't we? Yeah, we can. So we can subtract the mghf from both sides and get that negative mgh final is equal to 1/2 mv final squared. And then what happens with our m's? They're going to cancel. And then what are we going to do with this 1/2? We're going to multiply by 2. So we're going to have negative 2 g h final equals vf squared. And then what do we do with the squared? Yeah, we square root it. Okay? And since there's a negative here, shouldn't this number under the radical be positive? So do you think we're going to plug in positive or negative 9.8 here? We're going to plug in negative 9.8 so that we end up getting a positive under the radical, okay? So that means we're going to do square root of negative 2 times negative 9.8 times 0.64. And what you get here is going to be your actual answer for this part, for the velocity, because then we have to get the momentum. So what is it? 3 point what?
54 meters per second.
Mm-hmm. Okay, now is this one going to be positive or negative? I mean positive, right? Because we're going up now. Okay. So now that we have that, can we find the object's final momentum up here? Yeah, what are we going to do? We're going to do what times what? Momentum is equal to what times what, you guys? Mass times velocity. So we're going to want to say 0.015 kilograms times that velocity we just found of 3.54 meters per second. So what do we get as the momentum up here? And what are the units? kilogram meters per second. Okay. Now is when we look back at our question and we were asked for impulse. And what is impulse, you guys? It's a change in what? Momentum. Okay. So we are asked for when the marble bounces straight upward, what are the magnitude and direction of the impulse delivered to the marble from the floor, okay? So remember, this is the impulse of the marble as it hits the floor, right? And this is the impulse as it bounces up, okay? So that means that this would be considered our initial or final momentum. Which one? As it hits the floor, what is it? Initial, and this would be our final, okay? So we're going to want to take our final momentum, all right, and subtract our initial momentum. And then you're going to get the answer. Does anybody have it yet? You just had to subtract, you know.
0.13.
Yeah, 0.13 kilogram meters per second, okay? I want to say again, the reason I put this one on the problem set is because this lets you see how everything we've been doing this semester so far can be connected, okay? It takes that conservation of energy we just tested over, and it uses it to help us find momentum, which then helps us find impulse. Like I said, also, none of the other problems on your problem set make you do this, okay? So don't think you have to do this for every problem on the problem set. The rest of them are a lot more straightforward, okay? Do you guys feel like you're ready to start your problem set? Yeah?